Let's talk about the phases of digestion. So we've discussed what happens with food, but this is more of a neurological and hormonal component of this. So the phases of digestion, there's three: cephalic, gastric, and intestinal. So cephalic, head, you're thinking about food. Then the food goes into your stomach. That's at the gastric phase. Then the food goes into your intestine. That's the intestinal phase. They're kind of working against each other, but let's look at each one of them. So the cephalic phase starts off with thinking about food or smelling it or seeing food, and that all gets the brainstem activated. And we've got three different cranial nerves that are getting activated here: 7, 9, and 10. 10 is the vagus nerve. So we know the vagus nerve is going to continue on down, right? Because that one goes to the heart and to the lungs and to part of the digestive system. So that the vagus nerve is going down to the gastric glands, right? And then you have the 7th and the 9th. The 7th nerve is the facial nerve. So it's going to activate. So you've got three sets of salivary glands. You've got a couple under here: sublingual, submandibular, and then you got parotids on the side. And so the facial nerve is going to activate them, and the glossopharyngeal nerve, cranial nerve number 9, is going to activate down here. And so that's the cephalic phase. Seeing it, smelling it activates your brainstem. That's going to affect those three cranial nerves. Then you eat the food, and the food goes into your stomach. So the food going into your stomach acts as a buffer, and it's going to raise the pH. The pH is going to start to go up from 2. So that increased pH, less acidic pH, is going to trigger. It's going to activate receptors in your stomach. So you've got chemoreceptors and you've got stretch receptors. Stretch receptors, pretty obvious. Stomach gets stretched out, that activates stretch receptors. Chemoreceptors, they're getting triggered by the increased pH, meaning less acidic, right? And so that's going to activate the enteric nervous system. So you've got the receptors going up to the brainstem, and then you've got signals coming back down, activating the myenteric plexus. So remember back to the muscularis layer, and there's the myenteric plexus, and that's stimulated by, that's the ENS. And remember, this is rest and digest, so this is parasympathetic. So that's the neurological component. Gastrin, remember gastrin made by the G cells? Gastrin is going to relax the pyloric sphincter. So we call that gastric emptying. So by relaxing the pyloric sphincter, you're encouraging food to leave the stomach and go into the small intestine. It increases motility. So you're increasing the movement of the muscle. So you're making the stomach work faster, and you're making the food exit the stomach a little faster. Coffee, drinking coffee releases a lot of gastrin. So if you have to go to the bathroom after drinking coffee, that's why. So anyway, what stops all this is when you get the pH to drop back down to 2.0, or not exactly, but around back to its normal level, or the food leaves the stomach and then there's no more stretching. So this food's going into the intestine. Well, think about what the intestine wants to do. It needs to absorb things from the food. It needs to absorb amino acids and fatty acids and vitamins and minerals. All right. So when food gets into the intestine, it starts to stretch out. And there's stretch receptors in the intestine, and they're sending signals up to the medulla oblongata. They're trying to stop what the stomach's doing. So the stomach's trying to send food out, with gastrin, the small intestine is trying to inhibit the parasympathetic stimulation. So it's trying to slow it down because it doesn't want to keep getting food. It has to work through what it has. So that's one issue. You got to get the stomach. You have to tell the brain to tell the stomach to knock it off and slow down. Stop sending stuff to the intestine, the small intestine. Second, we want to get the pancreas to release pancreatic juice because that has two things in it. It has the enzymes to help break down the food, and it has bicarbonate, which is like an antacid. So we have two hormones in the intestine here that are going to work to do that. CCK, which stands for cholecystokinin. CCK is secreted by the small intestine, and that's because it notices that there's fatty acids and amino acids. And so it causes the pancreas to secrete its enzymes because you want all those enzymes, aminopeptidase and carboxypeptidase, whatever they were, trypsin, chymotrypsin, right? And also you want the gallbladder to contract because there's lipids in there. There's fatty acids. So you want the gallbladder to contract to release bile into the intestine. So that's what CCK does. Secretin is also encouraging pancreatic juice to be secreted, but for a different reason. CCK is making the pancreatic juice being secreted because it wants the enzymes. Secretin is doing it because the acid is stimulating secretin, so it wants to counter the acid. So it's trying to activate the pancreatic juice because it wants the bicarbonate. So both CCK and secretin cause or stimulate the release of pancreatic juice, just for different reasons. Secretin because of the acidity, that's the trigger, and CCK because of the molecules, because of amino acids, and fatty acids. That's the trigger. So this slide and the next slide summarizes. I took out in this slide summarizes the gastric phase and the intestinal phase. So those are the three phases of digestion. And I've got it summarized in these three slides: cephalic, gastric, intestinal. So I'd like for you to have an idea about those phases. And yeah, that is where I'm going to end it for this.